Good morning. I'm actually not sure if I've talked about this before or brought up that I was getting it, but I have ordered and been playing with a product that is essentially a reproduction of a 1970s Altair 8800 style computer. So, what did computers look like in the 70s? Well, I'm glad you asked. Mostly blinky lights. Like there wasn't a display on the computer itself. Like the Altair 8800 or the PDP-11. These were computers that you would program by giving instructions to them by flipping switches to set ones and zeros, and then hitting the save button to save that into a memory location. Right. So, this is my boy. It's the Digirule to you, and it brings the Digirule to you. It has 16 LEDs of output and 8 buttons for programming it. So you basically give it you go to a memory space, you navigate the memory space, and you enter instructions into that memory space using the buttons and flipping bits of ones and zeros and then saving it, and then you tell it to run that set of instructions. So the ability to play games, store information in a binary format, of course. You're also figuring out program flow and architecture for what you have to build on paper beforehand. Now, that might seem pretty useless, and it is mostly useless. It is mostly a learning tool and something for kind of exploring the process of computing, I mean. But it's something that I wanted to get because it was, well, so when I was a kid and I was kind of getting into computers, my best friend was taking a CS course at one of the universities nearby. So I was on the teaching myself route, and he was on electrical engineering and computer science route. And I did not know, this was at the point I knew very little and had difficulty learning anything about electrical engineering. I just had trouble with it. I couldn't grok. I didn't understand, and I don't do formulas. I do understanding. Once I understand something, then I understand how the formula applies. But if I don't understand it, it's like I'm reciting something. I don't understand it. I'm just saying it. I'm just memorizing it. But so that was something that was like kind of a roadblock for me. I could not learn electrical engineering. It didn't make sense to me, and that was the case for a very long time. But he was in courses and in class, and when I would visit him, he'd be working on some bit of code and would show me something, or working on a circuit, and he would show me something, and I'm like, cool, man. I don't get hardly any of that. And at one point, I remember this quite vividly. He was working on some code, it seemed, and what he had was a series, a long string of greater than and less than signs, possibly interspersed with some symbols. And I said, what on earth is that? And he said, this is assembly. And I was like, wow, that makes no sense. This guy is on another level to me. That makes me a little sad. Like I don't get that. I'm not even close to getting that. So assembly, that was my only introduction to assembly. And at no point did I ever have any professional interest or even personal interest in assembly until maybe a couple years ago, when I felt like I actually got to a point where I could understand it. So kind of always in the back of my mind was like, well, yeah, you're programming like this and like that, and yeah, you've accomplished these things and those, but like, you're not writing in assembly yet. So that kind of, I don't know, that kind of kept my interest on it. I mean, there's also the spectrum. What do I call it? I guess it is. Yeah, it is the spectrum. The spectrum of human language and then machine language, ones and zeros. And the question is, where is your language within that spectrum? Is it closer to human readable? Is it closer to machine readable? You know, and how understandable does it have to be, and how much are you willing to sacrifice for it to be more human understandable? And assembly is close to the lowest, closest to the machine code, closest to the silicon. And now that I know things about assembly, and know how assembly works, and know how program structure in assembly works, I am aware that I don't know what he was writing. He said it was assembly, and I don't know of any assembly that you would write like that. Also, the first thing you would probably do after writing something that you have to write that horrible mess of ugly looking string of code in that he was apparently writing, the first thing you would do is make a meta language to make that easier. I don't know why you would be doing that. And it might have been like a weird language that he was supposed to use as an exercise, but I know of no form of assembly that does that. I mean, I know there's the greater than and less than signs doubled up to indicate bitwise operations, but you still had numbers in there. You still had other operators in there, and operands. So I don't know. I have a suspicion at this point that it was just like messing with me or something. But it doesn't matter, because it got me interested in that base level computing. But you know, I was interested in what that spectrum of language is, and what the appropriate cutoff point is for whatever project. I guess that's another point. I would say there is very little reason to be programming a computer in ones and zeros. It's kind of just not that efficient, really. Unless that was all you had, or unless that was all you needed. You know, this Digirule. So when it was about to arrive, the first thing I was, you know, once I ordered it, I was like, all right, this is gonna be awesome. And it comes assembled. I was actually expecting to spend some time soldering it together. So I'm a little disappointed, but you know, whatever. I don't get to solder, no. So, like, what can you do with 16 LEDs and 252 bytes of memory? And the question is, not much. The answer is not much, but he can do some things. There's a rousing game of Kill the Bit, in which the LEDs flash of individual bit of a bit crawling across the LEDs, and you have to push the button on the bit when it lands there, and if you miss, it creates a new bit, and those two keep marching across. Well, you know, you can set the speed on that and adjust it. You can tweak the game a little bit. But I went back to, what do computers do? And they have, one of the greatest things is they have perfect memory. They can do odd calculations, they can do generic calculations, and they can keep time. So I wrote, when I knew it was getting close, or when I knew it was going to arrive soon, I was like, okay, once I get it, what am I going to do? I'm like, I don't know. Like, what would I do with it? I would probably want to write a program for it. So in reading the documentation and waiting for it to arrive, I wrote in assembly what I was going to write, what I was going to do for the timer program. I just wanted a 15-minute countdown timer, and then I wanted it to flash the LEDs once it was done counting down. And anyone following me on GitHub knows that that went up a little bit ago. But after writing that out in assembly, I looked at the reference documentation and converted all of that to ones and zeros. And then as soon as I got the Digirule, I powered it up. I started programming it. You know, first instruction is, it's got all the instructions on the back of it. It's a little cheat sheet. So your first instruction is speed. So that's 02 in hex. So you push this button so that lights up, and then you hit save, and it stores it, and then moves on to the next instruction. And then you set what byte value you want the speed to be set to. So CPU instruction speed, set to value, I think I do 8x, or 64. 64 speed. Next instruction. Now check the create an LED or save a value to a certain memory space, and from there on until you loop back on the instructions and let them repeat. And then when your countdown gets to 0, it jumps to the flashing area where the LEDs dance, so that you know what the time has run out. So when I got it, I ones and zeroed it all in, and I think I missed one bit or something because it didn't work, and I went back and reviewed it and went, missed that one, and ran it, and hey presto, it worked. So now you got to add new features to it, but it's interesting working in this smaller computing space, and it's interesting thinking about, you know, when you open up your Python interpreter and start typing into it, what you're doing is essentially flipping bits over there. You know, you've got obviously a bit more advanced. There's more registers available to it, but you know, this one has an accumulator, and I think it has an accumulator and another, like a reserved register, but everything else is just RAM access. I only have access to RAM to be used as data values or indirect pointers. So yeah, it's not weird. Yeah, it is weird. It's interesting, but it's interesting to figure out, you know, what you can get done with it, what you can do with it. So of course you get save slots for your programs, and the save slot is 252 bytes of data, and you get 8 save slots. So I wrote my timer program, and then I saved it to the memory slot that was pre-filled with the kill the bit game. And then because the kids, I showed them the kill the bit game, and they're like, what is this? Why? What is this and why? They're like, okay, they don't care about the kill the bit game. I'll overwrite this. So once I overwrote it, they came back and said, hey, how about that weird ant squishing game? Because that's, why should you kill the bit when you can just squish the ants? So I was like, well, I kind of deleted it, but I can write a new one for it. So I kind of went over that process with my son yesterday, because the code was already there, but it was there for an earlier version, so the instruction set was different. So we had to troubleshoot essentially our ones and zeros and change them so that they applied to the new version of instruction set, and then run it from there, and it worked. So now I had that extra program, and I'm like, well, kind of don't want to erase anything else in these memory slots. Like, well, I've also got, you know, the timer program takes up a small percentage of the 252 bytes available. I'll just record it in a later spot. So my memory slot 1 is filled with 3 programs at this point. I was like, well, I'll just memorize where those where those programs are in the memory, so that I can jump to them and then run them. Then I was like, well, why don't I make a table of contents at the beginning? And he was like, oh, we're beginning to make a file system. Like, this starts to make sense. The other thing about it is it has a USB Type-C interface on it. So you get a USB serial, you know, UART control where you can plug it into the computer, and then send data to it and give it logic to get data back from it. So you can control it from the keyboard. And some of these older computers, like the particularly the PDP-11, worked. You know, you get switches to flip and you get lights that blink, but you can't really do a lot with that. But if you were to plug it into a terminal, well, now you can program it from the terminal, you know, with a full-size keyboard and with a visual display output. So you can do that here too. It's just like light, low-level computing, and it's interesting to see what it can do. One thing that I do really like about it, though, is it doesn't take any power right now. It turns off and turns back on. Obviously, there's no boot. Oh, I mean, no, actually, there's technically there is a boot. It's kind of a memory test, and it's ready. So you get a little bit of a. I don't know how much of that is actually loading the operating system, because this does have an operating system. You're not programming the chip directly. There's some operating system that has to manage all the input of reading the buttons and which buttons are down and which buttons are up and what memory slot that data is being reset into, where the bits are being flipped. So it is an interesting toy, and I'm interested to know what I can do with it. I do have an outline for a game where you control with the buttons your LED, and it moves. You move it forward and back against someone else, and your object is to jump on them, so that when the LED moves to the next spot over, you jump on them, or you can flip to the next row and then jump up to get them. That's kind of maybe there's something about that. You do something with just LEDs, but being able to control it directly from a computer means you get like just straight LED output, and you can store 250 bytes times 8. You can store some bits of data on there. Use it as a password storage device. I don't know.